Hi everyone, I'm Govardhini Bobbili and I have worked with Meghana Chodavarapu. And today we would like to introduce a natural language processing topic, which is relation extraction. I'll continue to explain the various techniques, models, and applications related to it. And throughout this presentation, we'll discuss how relation extraction helps us to discover valuable information from unstructured data and its impact on various industries. In general, on a daily basis, we'll get huge amounts of information in the form of text, news articles, research papers, social media posts, and lot more. But all of this information is so random and unstructured, which is making so difficult and time consuming to analyze and understand the main content from it. Because of this, useful knowledge extraction from this data is difficult even for the machines because the relationship between different entities in the text is not defined or it's not structured. Relation extraction addresses this problem by identifying relationship between entities in the text and converting that information into structured knowledge. For example, if you consider this example of a car accident report, it says a car accident occurred on Highway 101 in Los Angeles yesterday, involving two vehicles and resulting in three injuries. This is a piece of information where a human can understand the example easily, but machine can't interrupt the relation between entities. So it can identify what kind of entities are present in the piece of information. Like it can identify Highway 101 as the location or Los Angeles as city, number of vehicles and injuries, number of injuries, but it cannot establish relationship between these entities. So understanding this kinds of information, the relationship between entities in this kinds of information is very much useful in drawing insights from this large text data, and this is very useful in healthcare, law and security kind of industries. Before we dive deeper, let me introduce the basic definition of relation extraction, which is it is a crucial task in natural language processing that focuses on identifying and categorizing relationship between entities in text. Entities are nothing but our daily things like people, places, organization, and dates. But as I discussed, just identifying entities alone is not enough. And then it really understanding the meaning of a sentence, we need to know how they are connected. So let me introduce the contrast between named entity recognition and relation extraction, because usually named entity recognition is a concept of natural language processing where machines identify various entities in a text. Basically, it focuses on identifying and sorting entities into real world things like people, locations, and dates, etc. If you consider this above example, which is Google acquired YouTube in 2006, a, a named entity recognition identifies Google and YouTube as organizations and 2006 as date. But in contrast, relationship extraction goes one step further by identifying how these entities relate to each other. It helps identify what is in the text, while RE helps us to understand how these entities are connected. This kind of relationship extraction is very essential for creating knowledge graphs and improving search engines. And it introduces this task do have some major challenges that often arise while extracting relationships, which are ambiguity, overlapping relations, and scalability kind of challenges. Ambiguity is the challenges which occurs when a word or phrase can have multiple meanings, which is making difficult for the models to determine the correct context. Here you can see the word Paris has three different meanings in three different contexts. Like it can be a name of a place, it can be a name of a person, it can be a name of a thing. So this kind of uh, ambiguity for the machines to interrupt is one of the major challenge in relation extraction. And the second one is overlapping relations. This is where this happens where same entities participate in multiple intervened relationships. For example, in an entity A being involved and related to both entity B and entity C in two different ways. This complexity increases the difficulty of accurately capturing all relevant informations in a single piece of text. Finally, scalability is a challenge because we usually deal with massive volumes of text, which is unstructured. So processing these large data sets quickly and accurately can be computationally expensive, and it requires efficient algorithms and better infrastructure. So if a model can't handle real world data sizes, it won't be very useful in practice. Understanding these challenges is very crucial for designing effective extraction systems. Further we go, here we see different types of relation extractions. Few of I would there are many, and I would like to introduce few of them, which is binary and array and open information extraction. The first one, binary relation extraction, focuses on relationship between exactly two entities, like X works for Y. So if you see this example, like X works for Y, the model identifies a single relationship which is worked for between two entities, which is X and Y. This type of extraction is often considered as a simplest one, and it is widely used in tasks like knowledge-based population or question answering. Where the next type, which is NRA extraction, goes beyond the pairs and can identify relationship involving three or more entities simultaneously. If you take an example of X, Y, and Z are board members of a company A, it can identify this array relation extraction can identify more complex dynamics and is very much useful in tasks like scientific literature or multi-party business transactions. And then comes this open information extraction relation. It relates entities without relying on a predefined schema or a structure or specific entity types. So it doesn't follow a predefined schema and essentially discovers the possible relationships in a sentence on a go. This method is very flexible when compared to others and can reveal novel relationships, but it also has its limitations as it produces more noises because it doesn't follow a structured schema. So binary extraction is very straightforward and it is widely used, whereas this NRA handles more complex scenarios with multiple entities. But the OpenAI offers more flexibility, but it also produces more noise. According to the application needs, we need to choose one of the approach among them. And then comes this popular approaches of relation extraction models, which are rule-based systems, supervised learning, distance supervision, and neural network models. These are few of the popular approaches. Let me go one by one. So the first one comes the rule-based systems, which employ a predefined pattern-based rules, which can be some simple keyword patterns or can be more complex syntactic structures. These are very easy to understand, but the implementation can be very solid, which makes them very less effective, and this makes them less effective when there is a change in the language or data conditions. Next, we have the supervised learning. Here we train models based on the labeled predefined data sets, and we use algorithms such as Navy Bayes or SVM or decision trees in this. These methods can achieve high accuracy with enough quality. All this is through enough training of the data. But the only thing is that it consumes more time and expensive when it comes to manual labeling of the data. To discuss about the distant supervision, it reduces the burden of manual labeling when it comes to action, and it automatically labels the data by aligning the text with the existing knowledge bases. This method scales better, but it can introduce noisy labels. Finally, the neural network models leverages deep learning architectures like convoluted neural networks and RNNs or transformers, where this model learn from complex features from the data automatically. However, they require substantial computational resources and large data sets. To discuss the real world applications and further scope, I let my friend to continue from here.
Hi everyone, this is Meghana. Now I'll be continuing relation action is used or applied in real world applications. First of all, before going into the application, you'll see the relation expression isn't just about identifying entity connections, but also driving impactful applications on techniques and use cases across various areas like knowledge graph construction, question answering, information retrieval, and drug discovery. Going into depth, the knowledge graph construction is about building a structural knowledge from unstructured text by identifying relationships between entities. So, this structured knowledge is then used to populate large databases such as Wikidata and database. So, this knowledge graph search helps search engines, recommendation systems, and virtual assistants to enable machines to better understanding and connect information between the text data. Next, going to the question answering, the relation extraction enhances the accuracy of this by understanding relationships between entities mentioned in the questions and answers. By linking the relevant entities, the system will provide more accurate context-aware responses. Going further, in information retrieval, the relation extraction enhances search engine capabilities by finding documents related to specific entities and relationships, ensuring a more relevant search results beyond just keyword matching. Coming to drug discovery. So, in this, it works or identifies by drug target interactions, which helps the discovery of the new medications by connecting the earlier scientific literature or the clinical data or the new research findings. Next, to effectively implement these applications, here are some tools and libraries for the relation extraction. So, first of all, the SpaceC is a high performance industrial grade NLP library that performs exceptional support for tasks like NER and dependency parsing, which is a fundamental for relation extraction. Because after dividing or converting the entities in the data, it helps for extracting a relationship in the data. Because of its ease to use and speed, it makes it a popular choice for production grade NLP pipelines to choose the spacey in specific projects. Next, we have the Stanford Core NLP, which is another comprehensive NLP toolkit that offers advanced relation extraction capabilities, which is widely used in the research and production management to analyze the grammatical structure of text and identify the relationships effectively between them. Next, the NLP is the another powerful library that focuses on research-driven NLP, making it a like excellent choice for experiment with the new techniques. Lastly, the Hugging Face transformer. These revolu- revo- revolutionize the NLP space by providing access to pre-trained transformer models such as BERT and GPT. These models not only enable the state-of-art performance in relation extraction, but also capturing complex relationships in text with remarkable accuracy. So each of the tools offers the unique strengths, making them as valuable assets for building efficient and scalable relation extraction systems. So the next slide is all about the future of relation extraction, which is a promising with advancements that will make it a faster, accurate, and more accessible. Now and this, few of them like the few short learning is which aims to address this by allowing models to abstract relations even in the minimal label data. So this reduces the annotation effort, making it feasible to deploy models in new domains with limited data availability. Next, the multilingual relation extraction. This broadens the applications by enabling to work across different languages. So, for instance, this model can process the customer feedback from different regions and identify common issues between them in all languages. The next is the explainable AI. So, this predicts a certain relation, increasing the transparency and trust on this. So this especially important in critical applications such as in healthcare, finance, and legal domains to give the accurate information and relation in the data. Next, incorporating knowledge graphs. This verifies the extracted relations and ensure consistency, improving accuracy and reducing errors. Taking like an example, a model extracting information from scientific papers and cross-check facts against established knowledge graphs to validate the relationship. So to conclude this, in a nutshell, relation extraction is a vital tool that performs unstructured into structured data and actionable insight. So throughout this presentation, we have seen various techniques, various models, challenges discussed by my friend, which are about this relation extraction task. So, despite all of these challenges, ongoing research and innovative approaches are continuously pushing the boundaries, opening up the new opportunities across diverse industries in healthcare, legal, and security. That's all for this presentation, and thank you. Thank you.